Hi all. Today we start discussing module 4. In this module we will discuss some methods to solve algebraic and transcendental equations. We already know how to solve quadratic equation, third degree equation and fourth degree equation, but for a higher order, higher degree equations, algebraic or transcendental equation, by a transcendental equation we mean an algebraic an equation involving circular functions, that means sine function, cos function, or logarithmic function, exponential function. Logarithmic function means log of something, exponential function means e power something, or 2 power, or any a power something is called the transcendental equation. Okay, algebraic equation means polynomial like equations. So we can easily solve algebraic equations of degree 3 or 4 or up to 4, but if you are given an arbitrary equation, there is no method to solve those equations other than this numerical methods. So in these sessions, in this module we will discuss some different kinds of numerical methods to solve those equations. Okay, so the idea is we first find an interval of unit length in which the roots lies. Okay, so if a and b are two consecutive integers such that f of a and f of b have opposite signs, then a root of f of x equals 0 lies between a and b. Okay, so that is the idea here. That means if we have this suppose we have a equation, we have an equation f of x equal to 0. Suppose we have this equation, and suppose the graph of this function is like this. Then we can say that if we need to choose two integers, consecutive integers a and b, such that f of a into f of b is less than 0. Okay, that means these should be these two values should be opposite signs. Okay, then that means if f of a is less than 0, then f of b is greater than 0, or you can expect f of a is greater than 0 and f of b is less than 0. If one of these cases happen, you can say that there is at least, that means here with this graph you can say that f of a is here. If this is the graph of f, then f of a is negative and f of a is positive. Okay, if you are considering this continuous functions, usually we are considering only continuous functions equations. That means f of x should be continuous. Then we can expect a 0 in between this a and b. Okay, so that is the idea here. So the basic idea of this numerical analysis is if a and b are two consecutive integers, if you choose an element, some c here, then c is another integer. If c is suppose we have a minus 1 here, then you can get the same idea. If we have if we replace this a by a minus 1, you can get f of a minus 1 is negative. Even though there is even though this f of a minus 1 is negative, then you can get a rooting between this a minus 1 and b, but they are not consecutive integers. So our intention is to get two consecutive integers a and b such that f of a and f of b have opposite signs. Okay, so that is the idea. That means in these methods what we have we are going to discuss, we first find an interval of unit length in which the roots lies. Okay, so that's the idea. That means if a and b are two consecutive integers such that f of a and f of b have opposite signs, then we can get a root of the function f of x equal to 0 lies in between a and b. Numerically, if we have f of a is negative and f of a is less than f of b, then we choose initial approximation as x equal to a. Okay, in the other case we choose b as the first approximation or initial approximation. Okay, which is the smallest value of f, then we choose the corresponding point as the first approximation. Okay, first approximation. So we are going to discuss the numerical methods. Numerical method means of course these are approximate methods. We will get the roots approximately, not need not get the exact one. Okay, so in the next session onwards, that is 22.16a, 22.16b and so on, we will discuss different methods of different numerical methods of solving algebraic and transcendental equation. So this is the first session, 22.16a graphical method. If you are given y equal to f of x, in order to solve this f of x equal to 0, you need to draw the graph of this. Okay, so y equal to f of x. If you draw the graph of this, and if you can get the abscissa, the value of x, we take the value of x in this way, and this is the value of f of x here, and this point, how to find out this point, that is the idea here. If you find out the value of this x at equal to c, that means the graph intersect the x-axis. Okay, and if you find that abscissa, that will be the root of this equation f of x equal to 0. So this is the idea. So in this method we will draw the graph of y equal to f of x. Okay, sometimes you can easily draw the graph of y equal to f of x. For example, if f of x equal to some x plus 5, then you can easily draw the graph of this. This is the first degree equation, then this is the equation of the straight line. Then you can easily draw the graph of this by putting x equal to 1. Then first of all, you in order to draw the graph of this function, you find out some arbitrary values. So this is here we have x, and this is f of x. If you put x equal to 1, then you can get y equal to 6, x equal to 2, we have this 7, and minus 1 you have 4, minus 2 you have 3, and minus 4 you have this 2. Minus 1 you have 4, minus 2 you have 3, minus 3 you have 2, and so on. So using these values, you can draw the graph of this function y equal to f of x. So x in this way and y in this way. So f of x in this way. And by putting 1, comma, here you can write this is 1, 2, 3, minus 1, minus 2, minus 3, minus 4, minus 5, and so on. And first of all, you write 1, 6. Okay, so that is 1, comma, here we write 1, 2, 3, 4, 5, 6. So this is 1, 6, this is the point. And 2, 7, that is, this is our 2, 7. And minus 1, 4, so that is here, minus 1, 4. And minus 2, 3. And minus 3, 2. So this is the 2 value. Now you draw this graph of this, you can get the straight line like this, which passes through these points. Then you can get at this point this y equal to f of x intersect this x-axis, then corresponding x value, that's the abscissa, is x equal to minus 5. Then you can get x equal to minus 5 is the root of f of x equal to x plus 5. So this is the way we use the graphical method to solve this algebraic equation. Okay, but in some cases it is not so easy to evaluate, easy to draw this graph. So suppose we have f of x equal to x square minus 5x plus 2. Okay, 5x plus this is 15. I write some 15. Then in this case, I'll write a simple equation first. So x square minus 5x plus 6. Then this is not so easy to draw the graph of this function. If in that case you need to find out the value root of this equation, then f of x equal to 0. So in order to get the root of this equation, we split this equation as x, or rewrite this equation as x square is equal to 5x minus 6. Okay, by transposing this minus 5x plus 6 to the right hand side, you can get this equation is equivalent to the same as this x square equal to 5x minus 6. So in this case, if it is not so easy to draw this graph of this, you try to split this into 2 by transposing some terms of this equation to the right. Then you can get two functions, f1 of x and f2 of x. Okay, we draw the graph of these two functions. You can easily draw the graph of these two functions because this first function f1 is nothing but x square, that is a parabola. You can easily draw the graph of this. If this is 0 and 1, this is 2 and this is 3, 4, these are minus values, and here we have positive values 1, 2, 3, 4, 5, etc. And here we have again 1, 2, 3, 4, 5, etc. Then you can easily draw the graph of the first function f1 of x. So we take f1 of x equal to x square, so that is a parabola. So that is minus 1, the value of 1 is minus 1 is 1, 1 is also 1. Here we have 2 at minus 2, we have 4, 2, we have 4. So this is the graph of the parabola. This is the graph of the parabola. Then you can easily draw the graph of the first function. Similarly, what is f2 of x? f2 of x equal to 5x minus 6. So this is again the straight line, so you can easily draw the graph of this. So by taking the values x and f of x here, when you put x equal to 0, then you can get minus 6, and x equal to 1, you have this is minus 1. By putting the value of x equal to 2 here, then you have 2 minus 2 times 5, that 10 minus 6, that is 4. If you identify this as a straight line, this is you need to take only 2 points. That is, one is 1 minus 1, that is enough. So that is 1 minus 1, that is here. Since this is minus 1, so this is the point here. And the next point is 2 comma 4, that is 2 comma 4, that is here. This is 2 comma 4, that is here. So if we write this as the graph of the straight line, since this is a straight line, we have draw the graph of this as this. Okay, so once you draw this graph, then you can easily get this point of intersection as this. So 2 is the point of intersection of this. If you choose x equal to 2, then left hand side will be 4 and right hand side also will be the same thing, 4. So this abscissa. Okay, if you are dealing with two such functions, then the point of intersection of the graphs of those two functions will give the abscissa of that. Abscissa of the point of intersection of abscissa means x value. X value of the point of intersection of these two functions will give the root of the equation x square minus 5x plus 6. Okay, so this is the idea. We obtain the root of this equation. When you put x equal to 2 here, then we have 2 square, that is 4. 4 minus 10, that is minus 6 plus 6, that is equal to 0. Okay, so this is the one way of getting one root of this equation. Now we will discuss a problem from the textbook. So this is not so simple problem. So first of all, we consider the question is this: draw the graph of y equal to e to the power x minus 1 and find graphically the value of the root of the equation 3 minus x equal to e power x minus 1. That means you need to consider this as two functions. Okay, so first of all you write this you write this equation. If you are given it's a complicated equation, first you write this as a single function, that is e raised to x minus 1, first of all you write this is 3 e raised to x minus 1 plus x minus 3. So this is our equation equal to 0. So first you find out values f of 1 equal to 1 plus if you put x equal to 1 here, then 1 minus 1 is 0, e raised to 0 is 1, and by putting x equal to 1 here, then plus 1 minus 3, so this will be minus 1. Okay, and if you evaluate f of 2, what is f of 2? That should be e, that is e to the power 2 minus 1 plus 2 minus 3. Okay, that is e minus 1. We know that e is, the value of e is 2.7 something, then this value is always positive, this value is negative. Okay, why we are finding these values f of 1 and f of 2? Since you find out these two values or two consecutive integers such that f of 1 is negative, f of 2 is negative, you can easily get or easily understand that the root of this equation lies in between 1 to 2. Okay, there is at least one root in between these two numbers. So it is enough to draw the graph of the functions. You are searching for the root of this equation, that means root of this equation. So we know that the root of this equation lies in between 1 and 2. So it is only to draw the graph in the interval 1 to 2. So it is enough to draw the graph in this session. Okay, then you can easily get at least one root from this. Otherwise, you may not know about the root. How can you draw the graph in a whole real line? That is not possible. Okay, so first of all you find out the interval, the consecutive numbers at which in that interval you should assure that there is at least one root in between them. Okay, that is the idea here. That's why we have find out this f of 1, f of 2, then you can get two different values, one is negative and one is positive. Then you can easily understand that there is at least one root in between them. So it is enough to draw the graph of this function. First of all we write f1 of x equal to 3 minus x, f2 of x equal to our first function. This is our first function. We take two functions. This can be considered as two functions, f1 of x and f2 of x. So f1 of x equal to 3 minus x, and f2 of x equal to e to the power x minus 1. So first of all we will draw the graph of f2 of x. In order to draw the graph of f2 of x, we need to find out the values of e power x minus 1. So first of all, how will you take the values of x here? So that is the idea. In order to get the values of x here, we are going to draw the graph in between this 1 and 2. So we start with 1.1. This is 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. Mark all those points up to 2. So 1.8, 1.9 and 2. Okay, we draw the value here, and here we write all the value up to some values 1.1 up to 2 or 2.8 or 2 or 3 or 1.2. These are values 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 9, 10, 1.9, and this is 2, and here we have 2.1 and so on. Okay, so we will find out all the values. This is x and this is our f2 of x. Here we have values 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9 and 2. We know that there is at least one root in between these two numbers, 1 and 2. So we write out all this. So using a calculator you can evaluate all those values of this. at x. Anyway, we can write one more thing. 1 at 1 we have 1. Okay, 1 point, that means it starts from this. Okay, this is 1, and 1.1 the value is 1.1052, 1.2214, 1.3499, and at 1.4 we have 1.4918 and 1.6487, and find out all those values as this. Then plot those values in the graph. Then you can get a curve like this. This is a curve like this. You can plot all those values. Then you can this is 1 point. At 1.1 we have this. Values, you can get the values like this. 1 point at 1 here, 2 here, 3 here, and so on. And draw the graph. This is the graph of f2 of x, that is e to the power x minus 1. You can draw it approximately anyway. And finally, if we write the graph of the values for f1 of x, that is 3 minus x. So the values are in order to get the graph of this, you need to worry about only 2 points, this x and y, and we know that at the point 2 we have this is 3 minus 2, that is 1, so that is 2 comma 1. This is the point 2 comma 1. Okay, here we have 1, so this is 2 comma 1, and at the point 1 we have at the point 1 we have 1 minus 3 minus 1, that is 2. So at the point 1 we have 2, so that is 2 here. Okay, so this so we draw the graph of this. This is the straight line. As this is the straight line, you can get the graph of f2 in this manner. F2 of x equal to 3 minus x. So then you can get the point of intersection of this. Then by projecting it to the x-axis, you can get this. This is the point of intersection, axis of the point of intersection of these two graphs. Then you can approximately write x equal to this 1.4 is the value of the root. So that is in fact this is I'll write it as. You can write it as in the. You can you can project it orthogonally to this somewhere here. So you can get 1.4 or 1.444 using the exact value here. You can get the value of x as the root of this equation. So this is the way we use the graphical method. So in the next class we will discuss bisection method and 2 or 3 other methods to evaluate this numerical roots of the algebraic and transcendental equation using numerical methods. Okay, thank you.